Today is day 2 of our content on chapter 4. We're going to be looking more at equations of lines. We're going to look at another way to write the equation of a line, and we're going to focus on parallel versus perpendicular. So first of all, slope between 2 points, we know how to do this. y2 minus y1 over x2 minus x1. That gives me my rise over my run, my vertical change over my horizontal change. And then again, different types of slope. Positive slope, if I'm going from left to right, I'm walking uphill. Negative slope, if I'm going from left to right, I'm walking downhill. If you have a horizontal line, that's slope 0. And if you have a vertical line, that would be an undefined slope. So quick review, slope-intercept form, y equals mx plus b. For this, remember we need the slope m of our line and b the y-intercept. So let's practice that really quick. I've got these 2 points A and B. This is going to be my x1, y1, and my x2, y2. So the first thing I want to find is m, my slope. So that's going to be y2 minus y1 over x2 minus x1. So that becomes plus. So that is going to be 3 over 1, which is 3. Now that I have my slope, I want to find B, my y-intercept, and I'm going to do that by plugging in one of these points. You can use the coordinates from A or B into your slope-intercept equation. So we're going to substitute M, we're going to substitute X and Y, and we're going to solve for B. I'm just going to go ahead and use the points from A. So that's going to be that negative 2 is equal to 3 times 3 plus B. Y-coordinate, slope, X-coordinate, B is what we're solving for. So 3 times 3 is 9, so I'm going to move over here just because I'm running out of room. So that's equal to 9 plus b, subtract 9 on both sides, and I find that b is negative 11. So the equation of my line is y equals 3x minus 11. Cool beans. Okay, so now parallel versus perpendicular lines. Remember, parallel lines have the same slope, and perpendicular lines have the opposite reciprocal, meaning that I flip my fraction upside down and I change the sign. So if it's positive, it becomes negative. If it was negative, it becomes positive. Okay, and then we're now going to look at another way that we can write the equation of a line, and that is one that's called point-slope form. For point-slope form, what you need is the slope and one point on your line, and this is the format. Y minus your y-coordinate equals your slope times x minus your x-coordinate. So let's practice that first. We're going to write the equation of a line passing through the point 6, negative 3. So this is going to be x1, y1. And it is parallel to this line. So if it's parallel, remember that means that they have the same slope. So I need to identify the slope of this line. And this is slope-intercept form, so I can see that my slope is negative 2/3. So I have x1, y1, I have my slope. I just need to plug those values into my equation. So that's going to be y minus negative 3 equals negative 2/3 times x minus 6. Now, this is the format. This is how I want to leave my answer, so I'm not going to distribute or move things to the side. All I want to do is take care of this minus and negative and make that plus. But this is the format, and I am leaving my equation this way because this is point-slope form. Okay, we are going to move on to the back now. And this thing at the top says, how do I show right angles on a graph? Now remember, right angles would be formed by segments that are perpendicular. So if I have perpendicular segments, then I know that they form a right angle. And I can verify that with their slopes. Remember, perpendicular lines have opposite reciprocal slopes. So if I am looking at the slopes of the two intersecting segments and they're opposite reciprocals of each other, I have perpendicular lines and therefore a right angle. So let's look at some examples of that. On this first triangle, I'm going to go ahead and label these points just to make it easier to see and know which point I'm talking about. So in triangle ABC, the one angle that looks like it could be a right angle is angle B. So let's determine that. I'm going to need to find the slope of side AB and slope for side CB. So let's look here first. Looking at the slope for CB, negative 1 minus negative 1 over 2 minus negative 3 That becomes plus, that becomes plus. I'm going to get 0 over 5. Well, 0 divided by 5 is 0. So this is a slope of 0, which I could have determined already just by seeing that this is a horizontal line. So let's see what the slope for AB is. Again, I'm going to do y2 minus y1 over x2 minus x1. And I'm going to get negative 4 over 0. Uh-oh, what happens when I divide by 0? It becomes undefined. And this is a vertical line. Again, I could have seen that from my graph, but a 0 and undefined slopes, those are actually opposite reciprocals of each other because 0 is going from my numerator into my denominator. So these are perpendicular, and angle B is a right angle. All right, let's look at our next one. These are already labeled for us. So in triangle EDF or DFE, EDF, the angle that could possibly be a right angle is angle E. So I need to find the slope of side ED and the slope of side EF. So I'm going to start with ED first. I'm going to do 3 minus 7 over 2 minus 5. That is going to be negative 4 over negative 3. A negative divided by a negative is positive. So the slope of this side is 4 over 3. Now I need to find the slope for EF. So that is going to be 4 minus 7 over 9 minus 5. So that's going to be negative 3 over 4. 4 over 3 and negative 3 over 4 are opposite reciprocals of each other, so angle E is a right angle. Okay, easy peasy. Now, since we are still talking about perpendicular segments and lines, of course, we are now going to talk about altitudes. Remember, the altitude of a triangle is a segment drawn from the vertex, and it is perpendicular to the opposite side. So, in order to find the equation for an altitude, I follow these 4 steps. First, I find the slope of the opposite side. I find the opposite reciprocal of that slope because, again, perpendicular lines. Then I'm going to find my y-intercept using the vertex and the slope and write my equation. And we can just use slope-intercept form again for that. So the last 2 steps are the same as it was for when we found median, but the first 2 are going to be a little different. So let's start with this example. I need to plot my points E, F, and G. So E is at negative 5, 4. There is E. F is at 2, negative 10. And G is at 5, negative 3. So I am going to connect those dots. And I'm just going to go ahead and label the coordinates off to the side because that's what I like to do. And I want to find the equation for altitude GH. So GH means that it's going to go from the vertex G and be perpendicular to the opposite side. So I'm just going to eyeball that. But I see that my opposite side is side EF. So when step 1 says find the slope of the opposite side, that means I'm finding the slope of EF. So I'm finding the slope for line EF. So if this is x1, y1, this is x2, y2. So it's going to be negative 10 minus 4 over 2 minus negative 5. Negative 14, that becomes plus. Negative 14 over 7 is negative 2. So there's step 1. Now on to step 2, I want to find the perpendicular slope, so the opposite reciprocal. So for line GH, that would be positive 1/2. Okay, now that I have my slope for GH, I need to find my y-intercept. So I'm going to do that with my vertex. G, this is going to be x, this is going to be y. So negative 3 equals 1/2 times 5 plus b. I'm solving for b. So this is going to be 5 over 2 plus b. I subtract 5 over 2 on both sides, and I get that b is equal to negative 11 over 2. So now that I have m and I have b, I can write the equation of my line. We've done steps 2 and 3. So y is equal to 1/2 x minus 11 over 2. Or you could say 0.5 and negative 5.5. Either way, we get the same equation, and that is our altitude. All right, and this will conclude our day 2 notes from chapter 4. Again, no proofs today, so you got off easy, and we will finish chapter 4 next time with some proofs on the equidistant formula.